I was educated at RISO some many years ago in a group that specialized in human-machine interaction. And in the meantime, this has spread into becoming human-computer interaction and now recently human-robot interaction. I have a background as a psychologist, so I am very interested in that interface between humans and complex systems and how to assist humans best in keeping an updated overview of what's going on in the complex systems and making the complex systems more competent by having this human operator to back them up. When their artificial intelligence fail, we can then kick in some human intelligence. We all know that autonomous systems have been working really well for a decade or three now in shielded environments like a factory, but it's a completely different ball game when we move out to the wild. We see autonomous or semi-autonomous cars being tested, and we see more and more features that we as drivers appreciate, but this well-known figure clearly illustrates that, well, we are somewhere between assisted driving and partially automated driving, while the tipping point for this industry is here between partially automated and highly automated. And I believe the basic takeaway point from my talk today would be, well, if we can't sort of just jump from today to the tipping point by technology alone, we could probably think of introducing people to make that gap. And then comes the question, how can we do this in a feasible way where this becomes cost efficient, safe, and so on? A lot of hard lessons have been learned when autonomous systems fail. These two examples is somewhere here, both of them related to Danish technology. On this side over here, you see a guy working on a campus in University of California, doing nothing but helping the transportation robots that Janus Friis is heavily investing in and developing when they get locked up somewhere in the corner of the campus. And the basic statistics says that up till now, half of the pizza deliveries out on the campus need him to come rolling on his Segway to help the robot out. So there is room for improvement here. At a local hospital, Herlev Hospital, they spent tens of millions of Danish kroners to have a huge installation of transportation robots in their basement. And it's been standing there now for more than a year. I don't know yet if it's up and running, but the main problem being that, well, it was efficient transportation system until humans started being down in those basement tunnels also. Then it got so confused that they stopped and they could not learn how to interact with the humans. And this is partly referring back to some of what Mads Bent said earlier on this morning. How can we make these robots show their intention and have some kind of simple interaction with people that meets them? We have been collaborating with the Danish facility management company ISS, and they have invested in quite a lot of autonomous floor washing machines. One of the first things that they realized that these robots are not really as autonomous as they would have liked them to be, because once they get out on the workplaces, people want to interact with them. And this goes all the way from just sort of playing with them, testing how clever are they by sort of walking in front of it, to actually obstructing it, closing doors in front of it, putting stickers on its camera, and so on. So we need to take all of this psychology, the social context around the autonomous systems into considerations also. How can we introduce a fleet of robots in a company where there will be people in such a way that the people accept them as colleagues, or at least smart equipment that they won't mess up with? That's one of the research questions that we have been addressing. Now, one way to do research is to take extreme cases, and I'll come back to that in a few minutes, but before that I would point at a Swedish project with a lot of emphasis on this person who is the driver of this remote truck. It was demoed first time in the Mobile World Conference in Barcelona. He could, by a 5G connection up to Göteborg, sit and control this autonomous truck that had been driving by itself all up to the final destination, and then he would take over and make sure that it would back in and be able to deliver its goods. So the business model of this company is that they will have fleets of these trucks driving down the highways of Europe, and then they will split out, being taken over by an operator somewhere that will then do the difficult parts of the last driving. This raises the question of, okay, how can we make sure that this person is actually competent in taking this on his shoulder right now? How can we ensure that he is not intoxicated? How can we make sure that he's actually the person that he identifies himself as being? There's a lot of issues here to be raised when we want to make these smooth handovers between autonomous systems and operators. This is also what was addressed within the maritime domain. How can we have remote ship navigators that would have the responsibility of controlling a ship in an open fairway? Now, when we design this kind of human-robot interaction scenarios, we like to take extreme cases, because this is really what's going to provoke new ideas and make us think out of the box, so to say. One case here was a severely disabled patient, not that patient on the picture you see here, but a patient with a serious disease, amyotrophic lateral sclerosis, that completely paralyzed this person, and he would very much like to be able to go around, and we've been working with this patient for many years, so we came up with the idea, maybe you could try then to use the last part of your body that you can actually control, namely your eyes, in order to control a robot. And I would like to show you just briefly how this works. Let me see, how do I start this? Yeah. Now what we do here, we put a head-mounted display with built-in eye tracking on this person's head, and now it's actually the eye movements of this person that controls where the robot is going to drive, not by setting waypoints, but a continuous driving principle. So you see he looks over there and then drives the robot in that direction. And in Unity we built this prototype interface where he can then call up, for instance, a typing interface to send a message to the person he's going to meet with, or send a PIN code to enter a door that he's going to pass through. We had a small map. This was built by Alexander Alapatide at the Alexandra Institute, also in Unity, and on this map he could then now set a waypoint, and by the collision avoidance systems of the robot, it would be able to drive down to that particular waypoint that was given to it. At that point, the operator would then again take over and be able to drive it into a manual mode. And in a manual mode, he could then turn around the camera as he likes to. If he's looking to the side of it, it will turn just slowly. Actually, you don't notice this turn because it feels really natural. This was at a conference a year ago where some of my students, or 2 years ago, they developed an interface directly from a wheelchair that would convert the turnings of the wheels into steering the robot itself. And the very sort of interesting thing was that everybody can do this right away, and you actually get a bit confused when you take off the headset because you were just over there being the robot and now you're back here in the seat. It's a really sort of captivating experience of you being embodied somewhere else, namely in that robot that you control. So next step, we went out with the Alexander Institute and tested this at an institution, people who are full-time wheelchair users, and my God, they were so good at driving these robots around. So this is actually what made us discuss with Mads Bent. Could we take advantage of that experience? Like Mads, he's been so many years in a wheelchair, he knows exactly how to drive these robots. Could we take advantage of that and suggest that we educate some of these wheelchair users to become the first generation of pilots for mobile outdoor moving robots? They have a lot of time and they would really like to be included in the workforce, I can tell. This is a project we demoed during the launch. It's a EU project where we are supposed to develop AR and VR exoskeletons that can help people recover from a brain stroke, so it will assist them in their daily operations, doing a little bit of that extra movements they need to be reminded on how to use their right hand for brushing their teeth, for instance. And one of our contributions to this will be that we'll focus on building a digital twin that would know what is this patient capable of. So how much extra force do we need to add for this particular person? This is the idea of a digital twin taken from Industry 4.0 over to become a personalized digital twin of a patient, and it could then become an in itself autonomous system that would try to adjust what would work best for this patient and do simulations on how to optimize on the extra force that it needs to push in to help this patient doing the motions right. You probably all saw how we could control the motions of a Lego exoskeleton that we made for just prototyping this. This is not how it's going to look in the final industrial version. The Icelandic company Össur is part of this project, so they are going to build the exoskeleton. But we wanted to have something that would make it possible for us to work with this integration between Unity and some cheap exoskeleton that we can just hand out to master students and let them go home and play with. We take heavily advantage of that machine learning component of Unity that makes it possible for us to integrate and communicate with the exoskeleton. Last example here of a recent project that we do with DTU Compute. We got funding from Synoptikfonden to develop the next generation of Vision 8 systems. So there are a couple of Vision 8 systems out there that are specifically meant for people who have low vision, and some of them are really bulky. They have sort of a hard load of hardware, software costs that makes them unachievable for quite a lot of people. that could really benefit from these systems. So what we have convinced the Synoptic Fund to support is an endeavor into building an open digital platform for vision aid systems that have this sort of base of the common belief that in a few years big companies like Apple, Amazon, Facebook will develop this smart glass that will make it possible for us to do these digital transformations of the visual field in front of the patient. Now, our special we have already done a couple of proof of concepts here, taking in the visual stream to a pair of VR glasses and then amplifying the borders makes it possible for people to see structures here in their environment that they have never been able to see before. And when we tested it out in home with some people with low vision, they really appreciated it. One thing that we discovered was that when we had left their home and they wanted to try it out, they couldn't find a pair of glasses that we had left with them. So we had to come up with an idea of how this could respond to them calling for where are this pair of glasses right now. This is the kind of insight you'd only gain if you actually produce an early prototype and go out and test it with people. Now again, the idea here being that we'll build a digital twin of the patient. We would train this digital twin with information on how do people with different kinds of low vision move their eyes around. This is actually what we have an expertise in, tracking eye movements, and we can do that from more and more devices. Now it's built into virtual reality headsets and will soon be built into smart glasses. So it's a free sort of sensor information that we can build on, knowing that this person never looks into this area is probably a good suggestion that this is a blind spot for the patient that we should avoid or somehow compensate for. And we can also have people with normal vision doing the same kind of daily task like making a cup of tea. And we can have normal vision people wearing these virtual reality glasses with video streams in and simulate that they have this kind of vision problem that we observe among some of our patients. And all of that being collected in a database and modeled for a digital twin that would then be part of this digital platform assisting people with low vision. I guess this will conclude my presentation.
Thank you very much, John. Very inspiring and giving the opportunity to see how technology can really help the life of people. Is there any question from the floor? Jacob first, I guess, then Alexander and Sylvia, if time allows.
Very short. Is it open, this one?
Yeah, just pressing the button on.
You were saying that in terms of these glasses or tinted glasses that you would collaborate with Apple and so on. I'm thinking about we are in the Osikon setting here today. We have three very strong hearing companies,
yes.
hearing aid companies.
Yeah.
They should be in the business.
Yeah. We are in a dialogue with these companies also, yes. Thank you.
Alexander?
Thanks for the inspiring presentation, John. I'm especially fond of the approach of using people who otherwise have some difficulties finding jobs to help with this new, quite large opportunity of assisting autonomous robots in the world. I know in the past you have tried to be in contact with different organizations and try to get some funding for that. And I was wondering how it's going. Have you received any or being in contact with any, for instance, ministry or some other high-level instances that could see a benefit for the Danish society in particular? Because I think there is a great potential there.
Yes, thank you. Yes, we have sent in a couple of applications now, which have been let down because we can't sort of prove the business model yet. But I actually supported Max Bent when he approached the new Minister of Transportation and wrote the minister a long letter arguing exactly what you just said, that this could become a new job opportunity for people. And so did Max Bent. I got a long reply back from the minister, but he did not. So I think we have a new sort of political situation now, and our current government, they put a lot of emphasis on this. So I'm hopeful.
Hi John, thanks for your presentation, very inspiring. I will have many questions, but just only one. Regarding the example you showed of the robot at Helio Hospital, you said that it was removed because it wasn't able to communicate with the people, right?
Well, it's not removed, it's still waiting to become operational, I think, yes.
So my question is, let's imagine that the robot was able to communicate with the people, was perfect, no? Do you think that people will have accepted that? And if not, what as roboticists we should take into account in order to increase the acceptability from people? Thanks.
I think it leans towards the research field of social robotics, and they have a lot of ideas that, for instance, if you put cartoon eyes on the robot, or you have a real person that when you call, the robot will respond to you, and this real person, he could be in charge of 100 of robots, just he would have to announce himself. But also, as Matt said, it's sort of being able to stop and do a little bit of dancing with people before you pass them, and not just sort of roll them over, right? So there's a lot of tangible things here, very delicate kind of social interactions that we should teach our robots.